Hello, dear faculties. This is Hemant from SmartInternz. I welcome you all for the day two session of Project Build-A-Thon. We'll get started at sharp 6:05 p.m. Thank you.
Hello all. I welcome you all to day 2 of the project Build-A-Thon. I hope I'm clearly audible. Can I get confirmation please? Thank you so much for your confirmation. So we are getting started with hands-on session from today. So I welcome you all on the behalf of SmartInternz team, and let me introduce myself. I am Shivani Kapoor from SmartInternz team, and I am an ML engineer. So I hope my screen is visible to you all. So let us begin with today's module, that is Python for data science. So let us first understand the agenda for today's session. So in today's session, we are going to have a introductory session for Python for data science, and then we'll be having hands-on practice with Python packages that we use for data science, and then we'll be working with IBM Cloud, exploring IBM Cloud services, and working with IBM Watson Studio Notebook. So we have yesterday learned about what is data science. So what is data science basically? Data science is about extraction, preparation, analysis, visualization, and maintenance of information. It is a cross-disciplinary field which uses scientific method and processes to draw insights from the data. So yesterday we have had an introductory session on data science, and I hope that it is clear that what is data science. So nowadays, whatever we are doing, even when I'm taking this session, I'm creating some data. I'm speaking, I'm creating audio data. We are recording it. We are creating some data. I'm sending a WhatsApp text. I'm creating a data. I am clicking an image. Then also I'm creating a data. Okay. So we have a lot of data. Like we are creating a lot of data, and data science is basically using the data for insightful purposes. So let us move ahead. So we are starting with Python. So Python was first introduced in 1991, like 1989, but it was officially available to public in 1991. So we can say that official date of birth of Python was February 20th, 1991. So Guido van Rossum is the father of Python. He developed and introduced Python in 1989 in National Research Institute in Netherlands. So now the question arises, why Python? Python is very easy programming language. We generally say that it is a general purpose programming language. That means it can be used for many purposes. It is a high level programming language that is easily understandable by humans. So there are some features of Python that makes it very simple to learn. It is also freeware and open source. It is a high level programming language, as I have already told. It is platform independent. Platform independent means that we write only once and run anywhere. Okay. It is dynamically typed programming language. That means no need to declare type of value, and when the value is assigned, automatically the type is declared. So it can be both procedure oriented and object oriented. It is interpreted language, and it has very vast amount of community and libraries that we can use, and it has very easy syntax. So Python, this makes Python am I audible? Sorry, this is not Red Hat. This is the session for ADS and data analytics track, applied data science and data analytics track. Mentors, can you please share Red Hat link in chat? So our mentors have shared Red Hat link in the chat. I hope I'm clearly audible now. Okay, thanks for confirmation. Let us continue. So we have different Python tools. We have Python code editors and IDEs. For example, we have Jupyter Notebook, Google Colab, Spider, Visual Studio, and PyCharm. So we have multiple packages for Python that we use in data science. So we are discussing 4 packages today, that is NumPy, Pandas, Matplotlib, and Seaborn. So let us get started with NumPy first. NumPy, as the name suggests, it stands for numerical Python. Numerical Python, that is NumPy, is an open source Python library that is used almost in every field of science and engineering. NumPy is a Python library that is used for working with arrays. So it provides basically ND array that we can use. It's the universal standard of working with numerical data in Python. And it's at the core of the scientific Python and PyData ecosystem. So basically, it is the foundational package for scientific computing in Python. NumPy, as I have already told, it stands for numerical Python, is a library consisting of multi-dimensional array, that is ND array objects. Using NumPy, mathematical and logical operations on arrays can be performed. Okay, so using NumPy, we can perform mathematical and logical operations on arrays. So why NumPy? In Python, we already have lists that serve the purpose of arrays. But why we are using NumPy then? Why we need arrays? Because lists in comparison to NumPy arrays is slow to process. So that is why we are using NumPy arrays. So we can perform multiple operations using NumPy. We can perform mathematical and logical operations using NumPy. We can perform Fourier transforms and routines for shape manipulation, and we can also perform operations related to linear algebra. So I hope I made it clear. So do we have any queries till now? So now we have understand what is NumPy. So now let us see how can we install and import NumPy. So basically, if we are working with Anaconda, so we can use Conda install NumPy, or we can use pip install NumPy. And when it comes to importing, so we have uh, methods to import, like we can import NumPy as NP. We can write import NumPy as NP. NP is nothing but the alias name that we give to NumPy. That is, whenever we have to use NumPy, we always do not have to write NumPy. We just write the alias name, that is NP. Okay. So this was all about the introduction of NumPy. Let us move ahead to Pandas. So Pandas is another very useful library, of Python that is very widely used for working with data sets. It has functions for analyzing, cleaning, and exploring, and even manipulating the data. So Python provides us with three different type of objects, that is series, panels, and data frames. The name Pandas has reference to both panel data and Python data analytics, and was created by McKinney in 2008. So why we are using Pandas? So Pandas is an open source Python library. It is a high performance data manipulation and analysis tool. It is used in a wide range of fields, including academic, commercial, finance, economics, statistics, analytics, etc. So Python allows us to analyze big data and make conclusions based on the statistical theories. Python can clean messy data sets and make them readable and relevant. Relevant data is very important in data science because we cannot just directly apply any algorithm on the data. We have to make the data relevant to be trained on. So there are some features of Pandas, that is, it is fast and efficient. It has fast and efficient data frame objects with default customizing indexing. It has tools for loading data into memory. So basically, if we like in other programming language, we make connection with the data set. Here we have Pandas that can itself read the data set. It can read CSV data, it can read Excel data, and it can read JSON data and all. So we can data alignment and integrated handling of missing data is also possible with the help of Pandas. We can reshape and pivot the data set. And it has label based slicing, index, and subsetting of large data sets. In Pandas, columns can be deleted or inserted. Group by for aggregation and transformation can be used. It is a high performance merging and joining of data. It is a high performance tool for merging and joining of data. And it provides time series functionality also. So that is why we are using Pandas. So now we have learned about Pandas. Now let us see how to install and import Pandas. The command is same, just we need to change the library. For example, we have to just, if we are using Anaconda or Miniconda, we have to write Conda install Pandas. Or it can be installed by pip command also, that is pip install Pandas. And then when it comes to importing, we can import it as import pandas, or we can give an alias name to pandas, that is PD, or any alias name that you want to give. So this was the basic intro about pandas. Now let us move ahead with matplotlib. Matplotlib is a library for Python programming language, and its numerical mathematics extension NumPy. So basically, matplotlib in combination with NumPy is used to perform many different visualizations and analysis on our data. It provides an object-oriented API for embedding plots into applications and general-purpose GUI toolkits like Tinker, WXPython, Qt, or GT. Matplotlib is an amazing visualization library in Python for 2D plots. It is one of the greatest benefits of visualization is that it allows us to visual access to huge amount of data in easily digestible visuals. So matplotlib consists of several plots like line, bar, scatter, and histogram. We will have a hands-on session today on these different plots. So now it comes to installing and importing matplotlib. So when it comes to installing the matplotlib, we have different commands like conda install matplotlib if we are using anaconda or miniconda. Otherwise, we can use pip command also, pip install matplotlib, and we can import matplotlib in like this, like we can use import matplotlib as import matplotlib as mpl, or import matplotlib.pyplot as plt, that is an alias name. And as I have already told you that we use it with the combination of NumPy, so we will import NumPy also. Now it comes to Seaborn. Seaborn is another library that is used for data visualization or data analysis, we can say. So Seaborn is a library for making statistical graphics in Python. It builds on top of matplotlib and integrates closely with pandas data structure. So as in matplotlib, we use it in combination with NumPy. In Seaborn, it closely works with pandas data frames. Seaborn helps you explore and understand your data. That is what visualizations is. Visualization helps us explore and understand our data, know more about our data. Its plotting functions operates on data frames, as I have already told, and arrays containing whole data sets, and internally perform semantic and statistical aggregation to perform informative plots. We'll have a hands-on session on all these packages today. So now when it comes to install, we have the commands conda install Seaborn if we are using anaconda or miniconda, or we can use pip command also, pip install Seaborn, and importing is same, like we have to import and give the name of the package, that is Seaborn, as SNS. SNS is nothing but the alias name we are giving. So now let us get started with IBM Cloud. So as in yesterday, in the introductory session, we have already learned about cloud platforms. So Today we are going to work on a cloud platform that is provided by IBM, that is IBM Cloud. For that, the basic requirement is that you need to have your IBM account. So I hope all of you have your IBM accounts. Sorry, sir, you want me to repeat? Seaborn, right? So Seaborn is a Seaborn is a library for making statistical graphics in Python, and it is built on top of Matplotlib, and it integrates closely with Pandas data structures, that is data frames. So Seaborn, we closely work using Pandas data structure. So its plotting functions operate on data frames and arrays containing whole data. Okay, and it internally performs necessary semantic mapping and statistical aggregation to provide us with very informative plots. So do we have any query till here? Sure, ma'am, the recorded video will be provided. So basically, you can get access to your recording in respective SmartInternz educator login. Under learning resource, you will find the recordings. So now we are beginning with the hands-on session. So I request you all to please go to cloud.ibm.com. I request you all to please go to cloud.ibm.com and log in using your credentials. Yeah, the link is already provided by the mentor. Please go to that link and log in with your credentials. I request you all to please log in. So after logging in, you will be routed on to the dashboard that is looking like this. So I hope we are on the same page. If you don't have IBM account, ma'am, you need to create your IBM account. I have shared Telegram link in the chat. Those who are not there in Telegram channel can join. So when we land onto the dashboard of IBM Cloud, it is looking like this. Here, there are many services that are provided by IBM. To see those services, we can directly go to the catalog from the main navigation bar. I request you all to please go to the main menu and go to catalog. From the main menu, you have to go to catalog. I hope I'm audible. Hello. I hope I'm audible now. Sorry, there was some network issue. I got disconnected. So from the dashboard, we have to go to the catalog, and here we can see multiple resources that are provided by IBM. So here, if you click on your left hand side, if you see the categories, if you go on to AI and machine learning, you can see different machine learning services like Watson Assistant that is used to create chatbots, Watson Studio that we'll be using today. It provides us code editors and free model building tools. Then we have communication monitoring, another service that is used to that is used for voice and text analytics. IBM Mesh 360, Knowledge Studio, Language Translator, and so on. We have a lot of services provided by IBM. If it is asking for payments, so you may not have followed the complete steps that are given in the reference video. If you may have followed the steps, then you may not get this issue. The recordings will be provided and the support will be provided. You can please request for SmartInternz ID and you can create your IBM account. So here we can see the multiple resources that and the multiple services that are provided by IBM. So now, without any delay, let us continue with creating the services. So here we need to create some basic services. Okay, the first one we need to create is object storage, because whenever we do any project, so we need some storage space. So this object storage is the cloud object storage that will be provided. So please search for object storage. This the first option named object storage will be there. You have to select this object storage service. When you select the object storage service, you will be landing onto a page that is having this icon and saying the cloud object storage. Here, you do not have to change anything. We need to, we want IBM Cloud, and then we have to click on create. We have to click on create. I repeat myself, on the catalog, you have to search for object storage. You have from the drop down, you have to select object storage service. You will be landing onto this page. Nothing to change here. You just have to click on create on your right hand side. When you click on create, your service will be creating. And when your service is created, you will be landing on to a new page of the cloud object storage service. That means you have already, Mr. Deepak Gupta. That means you have already created the service, so you cannot create it again in the free account. In the trial account, you cannot create it again. Yes, I repeat. I repeat the steps. After landing on to the dashboard, you have to go to the main menu and click on the catalog. When you go to the catalog, you have to search for object storage. When you will be routed to a new page. There on your right hand side, you will be having a blue create tab. You have to click on that blue tab. You need academic ID for the registration. Card. Yeah. So when the service is created, we'll be landing onto this page. After creating cloud object storage service, we need to create machine learning service. Sorry, we need to create Watson Studio. We need to create Watson Studio. So here you have to select the location as Dallas or London. I prefer Dallas. So you can select any location, but you have to just take care that what location you are selecting for a service, the location should be same for all the other services. Yes, I repeat, go to the catalog, go to the catalog. Here you have to search for Watson Studio. Click on Watson Studio, you will be landing onto this page. So here you have to select the location as Dallas or London. You can select other location also. I prefer Dallas or second preference is London. So when you are here, when you select Dallas for one service, you have to select the same location for other services also, so that the location do not create any conflict. So please keep in mind that what location you are selecting for a service, the location should be same for other services also. Then you have to check the license agreement box, and then the create tab will be enabled. Then you have to click on create. Check the license agreement box and then click on create. Click on create. Sure, sir. I'll wait for 2 minutes. Can you please reload if it is taking if it is not loading the object service page, you can refresh it or reload it. Karthika, Miss Karthika, you'll get it when you go to catalog. I'll show you again. You have to go to catalog and then you have to search for Watson Studio. This is the Watson Studio. So now it will not allow me to create another instance as I have already created one. So I hope now you all are able to create object storage and Watson Studio. Okay. So now I have when you will be creating the Watson Studio service, you will be landing onto a page. I have changed the page, so I have to go to the resource list. So on your left top, you have the navigation menu. From here, you can go to the resource list. And under the services and software, you can find Watson Studio and storage will be under cloud object storage. So I'm clicking on to Watson Studio. So you guys, you all maybe may land onto this page after creating Watson Studio service. May I know the issue, ma'am? What Miss Anjali Deshpande, what is the issue you are facing? It is same, ma'am. What happens is that for every every other account, this code will be unique. So my code and your code will not be unique. It will be different. So when we are onto this page, we have to just click on to launch in IBM Cloud Pack for data. Launch in IBM Cloud Pack for data. So I have previously created the service. So I am landing onto this page. What you can do is you will get a page where it will be asking you about your college, about your company name, where you can give your college name and give your contact and continue. Yeah, I'll wait for 2 minutes. So if you follow the steps that are given in the reference video, it will not ask you to pay. I hope the reference video is provided. So I'm repeating the steps. You have when you log into the dash, when you log into your account, you will be landing onto the dashboard. From there, you have to go to catalog. There you have to search for object storage. You will be landing onto a new page. From there, on your right hand side, you will be having a create option. You have to click on that create option, and then your service will be created. Then you have to again go to catalog. After going on to catalog, you have to search for Watson Studio service, and then you have to select the location as Dallas or London. I prefer Dallas. On your right hand side, you will be getting the create option enabled when you click on the license agreement. After clicking on the license agreement, the create option will be enabled, and then you have to click on create, and you'll be landing onto the Watson Studio page. Then you have to click on launch in IBM Cloud Pack. You have to give your college name and your contact, and you will be landing onto this page. I hope you all are here with the on the same page with me. So without wasting our time, let us begin. So here I have already created a project. So that is why this is visible to me. For you, it will not be visible. Or otherwise, what you can do is you can go here, click on view all projects, click on view all projects, and here you will be able to create the new project. So I am clicking on the new project. Click on the new project. After clicking on to the new project, you have to click on create an empty project. Create an empty project. Create an empty project. Then you have to give your project name here. So I am giving it as demo. Here you can give the description. It is optional, so I'm not giving. Here your cloud object storage will be auto-populated if you have created it. If it is not auto-populated, that means you have not created cloud object storage. So after giving the name, the create option will be enabled. Then click on create. Click on create. I hope we are on the same page. So after learning on to this page, so when you click on new project, so it will be taking you to a new page. There you can select an empty project. You have to click on new project, then you have to click on create an empty project. Yeah, instead of your company name, can you please have to you can please give your college name and your contact. If it is disabled, you may not have selected the country code from the drop down. Can you please select the country code from the drop down? Uh, I hope we are on the same page. From here, we have to go to assets. And now we need to do hands-on practice. So for that, we need to create a new asset that is a code editor. So here the code editor, that is Jupyter Notebook Editor, is available. I click on Jupyter Notebook Editor. And here I give the name to the notebook as from the asset, you have to go to code editor and you have to select Jupyter Notebook. Then you have to give the name to your notebook and then click on create. So we are starting with NumPy practicals. I hope all of you, like we all are on the same page. I hope we all are on the same page. So the first thing is we need to import the package, import the library. That is, we have to import NumPy. So to import NumPy, we can simply import NumPy like this, import NumPy. Or what I can do, I can give the alias name that is NP, that is NP. Why I am giving this alias name? Because if I'll be using any of the function of NumPy, so I have to give the reference of NumPy, that is NumPy dot the function name. So using NumPy each and every time will be somewhat hectic. So we are giving a short name to it, that is NP. That is NP. And you can run the cell using this run command, or you can use shift enter as a shortcut. So you can find the code editor under the assets. You have to click on new asset. And from there you have to go to code editor and you will be landing onto this page. I hope we all are on the same page. So here, whenever we need to use any function of NumPy, then we can use it like np dot function name okay. For example, as I need to create NumPy array. So np dot array. This is how I can use NumPy. So basically the function that are provided by NumPy, I have to give reference of NumPy here. So that is why I have taken the short name for NumPy, that is NP. Otherwise, I had to write NumPy every time I use any function of NumPy. Okay. So now I am creating a list. Now I want to convert this list to an array. So what will I do? I'll create a variable, and here to this variable I am assigning np dot, and here I am passing this list that I have to convert into array. And run the cell. Okay. So I have executed the cell. Now let me check the type of list one. It is list type. It is the type of list. And now let me check the type of array. You can see it is NumPy array. ARR is NumPy array, and list is type of list. Okay. So I can perform. I've done here after this function name. I have created this list, and then I have converted that list to array. And then I am checking the type of list and array. So when I check the type, I got to know that list one is the type of list and ARR is the type of NumPy array. Okay. After that, let us move on to some inbuilt method to create NumPy arrays. So we are checking for built-in methods for NumPy arrays. So let us first start with arrange. np.arrange is used to create array in the range of the given specified value. So this is the end value, that is the stop. Okay. So here When it comes to arrange, so we have np. Its syntax is like np dot arrange. Then we have start here. Start. We can give stop. We can give jump. And here we can also give the data type. That is D type. Okay. So these are the parameters we are giving. So stop is the required parameter. So I have given this stop. So if you see, so it is starting from 0th index. It is starting from 0th value. So it will work till 9. That is n minus 1. If we have given the start value 10, it will work till 10 minus 1. That is 9. So from 0 to 9, 10 element will be having. Okay. So now, if I want my array to start from 3 and end at 8. So you can see 3, 4, 5, 6, 7. 7 because it is taking n minus 1. For stop, it is taking n minus 1. That is 8 minus 1, 7. So it will work till 7. 8 is not included. 8 is excluded. Sir, if you have given a Miss Apeksha Mohite, if you have run this cell, that was you can run that as a comment. I have just told you the syntax. If you see here, this is the type of row ND convert. This is not for type of cell. Instead of function name, you can give array and you can check. Okay. So this is how we can give start and stop. So we can start the array from the desired range and stop at the desired value. Okay. So now I am creating an NP array. I'm starting from 11. I want to stop at 30. So I'm giving 31 and I'm taking jump of 2. Okay. So this is how it works. Now I want to define the data type also. I am starting with 5, ending at 20, giving the jump of 3, and the data type I want is float. So you can see now my data is type of float data. You can see the decimal points. Let us work with another built-in function that are zeros and ones. Zeros and ones are used to create array of zeros, all zeros or either all ones. Okay, so for zeros, I'm simply writing np dot zeros, and then we can define the shape. So I'm giving shape as 3. Okay. So by default, the data type here is float. So if you want to change the data type to int, you can do that. Then we have np dot one, and shape I'm giving is 6. So it will create the array of 6 ones, as I have given the shape as 6. So now if I want to create 2D array, if I want to create 2D array, so I can create, if I want to create 3 by 3 array of 1, I can create it like this. Okay. Similarly, in the case of zeros also, I can create 2D arrays like this. Now, the next inbuilt array is linspace. So, what does linspace do? Linspace gives us linearly spaced value between the given range, that is start and stop. Okay, so it gives us linearly spaced value between the given range. So let us proceed with linspace. So I am giving start value as I am going to start from 1. Stop value as 10, and between 1 to 10, I want 5 linearly spaced values. I want 5 linearly spaced values. Sorry, I have given 3. I want 5 linearly spaced value. So between 1 to 10, I will be getting 5 linearly spaced values. Linearly spaced value means the difference between first and the second value will be equal to the difference between second and the third, and so on. Then we have I. So np dot I is used to create array having only the diagonal value as ones, other all values as zeros. Okay, so here I have to give n is equals to 3. Okay, if I give 6, I'll get 6 by 6. But if I want to give the value of rows and columns both, I can give it like n and m. So I'll be having 6 rows and 3 columns. So here N stands for rows and N stands for column. If I do not give the value of any of them, so it will be take a, like, if I have not given the value for M here, so it is taking a 6 by 6 matrix. It is taking N by N matrix you will get. And here if you want to change the data type, you can also change the data type. So data type equals to int. Yes, we can change the data type of an array. Now we have some inbuilt function that are some random functions. We have some random functions. So let us look at the random function. So we have three different type of random functions. The basic rand, rand, then rand int, and then rand n. Okay. So here we are starting with random functions. np dot random dot rand. So I'll get a random value. Every time when I run this, I'll get a different random value. Every time I run this, I'll get different random value. Okay. Now, if I give a specified number here in the argument, so for example, I'm giving 3. So here I'll get any 3 random value. I'll get any 3 random values. Okay. And if here I give rows and columns, so I'll get 3 rows and 5 columns of random values. So I'll get an array of 3 by 5 having all random values. Every time I change it, the values get changed. Then we have rand n. Then we have rand n. Here we get normally distributed random values. So here the values we get will be normally distributed. Random is random normal. That is normally distributed random values we will be getting. Then we have rand int. Then we have um, okay. So what happens here is within the range of 5, I will get a random value. That is an integer value. Okay. So if I run it, it will give me a random integer value within the range of 5. Okay. So now if I want the value within the range of 1 to 50. I'll get one random value within the range. Okay. If I want it to 20 to 50, I'll get the value between this range. Okay. And here I can also give the number, how many random values I want. If I don't give any number here, that means that it is taking in rand and we get normally distributed random values. Here now I want 5 random values. So you can see we have got 5 integer values within the range 20 to 50. So basically we can say that this is the start point, this is the stop point, and between this range we are getting 5 random values. So this is what all about NumPy. This was all about NumPy. So now let us begin with the next package that is pandas. So let us get started with pandas. So the first step is to import the library. So import pandas as PD. Import pandas as PD. So pandas provides us with multiple objects, that is series and data frames, also panels, but we generally use series and data frames. So series is basically a one-dimensional labeled array. It is homogeneous array and it is data mutable and size mutable. Okay, so how do we define a series in pandas? How do we define a series in pandas? Please note this is a syntax. I'm just telling the syntax. Do not execute this cell as code. If you are executing it as a code, please give a hashtag to make sure that it is a comment. So pd dot series, 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 and in the series make sure you are making the S capital. Then you have to give the data that you want to be there in the series. Then you have to give the index. So you can give the index values yourself. So it is labeled 1D array. It is labeled 1D array. Then you can give D type, that is data type, and if you want to make copy of it or not. Okay. So series can be created using various input like arrays. You can create series using dictionaries. You can create series using scalar value or constant values. You can create series. Hello. I hope I'm audible. Okay, so I'm repeating series. So series is one-dimensional label array that is provided by data frame like pandas. It is homogeneous type of array, data mutable and size mutable. With the it is data mutable and size immutable. That means that we cannot change the size of the series, but we can change the data. So series can be created using various inputs like from an array we can create series, from a dictionary we can create series, from scalar value or constant values we can create series. So now let us move on to creating a series object. So firstly, I am creating a series that is data using a list. So I am giving some values in the list, that is 2, 3, 4. Okay. I have executed this code cell. Now I want to check the value in the data. So if you see that this is a 1D array, 2, 3, 4, 5, 6, 7, 8, 9 are the values, and 0 to 7, these are the index of these values. These are the index of these values. Okay. So if I want to change the index, I can also change the index. So here, if I want to check the values in data, so data dot values, these are the values in data, and data dot index. So index of data is, sorry, I have put comma. So index value is starting from 0 and stopping at 8, and step is 1, that is 8 minus 1, that is 7, and step, that is 1, that is there, means there is no jump. So it is starting from 0, 1, 2, 3, 4, 5, 6, 7. Okay. So if I want to change the index, I can change the index also. For example, if I want to change the index of data, so here what I can do, I can give index, and for index also I can give an array A, comma B, comma C, comma D, comma E. So we have to put these characters in these string values in quotes. Okay, now let me see the data. Now let me check the data. Now if you see the index is changed, the index is changed. Now, if I want to access, this 4, if I want to access 4, then what will I do? I can simply type data, giving a square bracket, and then give the index. 4 is at C index. I am getting 4. Also, I can simply write data and give the as 0, 1, 2. It is at second location. Okay. Now let us create series as a specialized dictionary. You can use single quotes also. Single quote and double quote will work. So now we are creating a series as a specialized dictionary. So from the dictionary, I'm going to create the series. So I am first creating a dictionary, population. I'm giving the state name and population. So I'm giving any random value for the population. These are not the exact values. Texas. Sorry, in the dictionary, we have to put colon, not equals to. Florida, and the population for Florida also random value. So I have created this dictionary that has state name and values for that. Okay. So now let me check my population dictionary. And let me check the type of this. It is dictionary. Okay. Now we want to create a series. We want to create a series population. I want to create a series population. So population is equals to pd dot series. So I am creating a series from a specialized dictionary here, guys. And here I am passing the data as population dictionary. Okay. So when we give dictionary to the series, then the keys become the index and the value become the values. Okay. So this happens when we create series from a dictionary. So now, if I want to access Texas, so I'll get the Texas location, Texas population. So now I want to access from Texas to the last, that is Florida. So you see from Texas to Florida, I'm getting it all. Okay. So this is how you can fetch values from a dictionary. Oh, sorry, a series. Now let us create another dictionary, that is area dictionary. So I'm using the same, I'm copying the same, but I'll change the values. Area dictionary, and I'm changing the values here. Okay, so this is the area dictionary I have created. This is the area dictionary I have created. Now I'll be forming a series of this. I'll be creating a series of this. So area equals to pd dot series. So I have created another series using the area dictionary. So now I have created two series. I have created two series. One is population and the other one is area. Other one is area. Now let us move on to the next object that is provided by pandas. That is provided by pandas. That is data frames. Let us move ahead with data frames. Okay, so data frame is a 2D dimensional object that is provided by pandas. It is site mutable and it can be heterogeneously typed. It can have many heterogeneously typed columns. Okay, so it is the data frames are in a tabular format. We get the data frames in a tabular format. So data frames can be created from series, arrays, and different type of values. So now let us create our data frame using the two series that we have created. So I'm creating a states data frame, and here pd dot data. So please keep in mind whenever we are creating a data frame, so we are using the function that is dot data frame. So where D and F needs to be capital. D and F should be capital. So I am creating a dictionary here. So I'm creating a nested dictionary. I'm creating a nested dictionary. So in this nested dictionary, I'm creating the first key as population, and the value for this is the population series. And same for area. Now let us check the states. PD is an alias name for pandas. PD is the alias name for pandas. The short name we have taken for pandas. Okay. So this is how we get a data frame. So in the data frame, you can see that this population and this area are the column names, and the main motive to keep the states same was to keep it like this, to get it like this. Okay, so I have got the index as the state's name. Okay, so here I have got the state name, the population, and the area in a data frame. So this is a two-dimensional array. Okay, two-dimensional object provided by pandas that is able to read 2D data and present it in a tabular format. Okay, so here we can also change the index, we can also change the column names. So now let us check the columns. So we have two columns, population and index. Similarly, we can check the index. Yes, we can add the column. Up to what cell? Can you please tell me the cell number? So let us perform some statistical functions. Let us perform some statistical functions on the data frame. So if the indices were not same for population and area, then what happened if California is in population and not in area? Okay. If California is in population but not in area, then we will get a null value here, nan value. Okay. And okay. So now let us perform some statistical functions. So let us first perform states.count. So in the population column, we have 4 values. In the area column, we have 4 values. Okay. Then we can perform states dot sum. So the sum of all the values in population column and all the values in area column. States dot mean. States dot mean will give the mean value of both respective columns. So for the population, the mean value is this. For the area, the mean value is this. Similarly, we can find out the median. Similarly, we can find out the mode. So all the values are unique here. That is why we are not getting mode. Then we can have the standard deviation also. STD is used to find the standard deviation of the particular column. Then we can have the minimum value and the maximum value of this also. Then we have this states dot info function that will give us all the information regarding all the columns of in our data set. So here we have the data set states. In the states data set, we have 2 columns, that is area and population. So we have 4 entries, that is 4 rows, and 2 that is California to Florida, the index. Then we have 2 columns, population and area. There are four not null values in population and same as in area. The type of data in states in both the columns is int. Ma'am, we'll be using these functions when we'll be performing data pre-processing. You will get the use of this. Then we have state dot describe. Basically, these functions are giving you analysis of your data. You are getting to know more about your data. Okay, so it is giving you the minimum value, the maximum value. To perform some numerical operation on it, you must be knowing the minimum value or the maximum value of the function. So this is what info does. Oh, sorry. So we have a function called describe function. In describe function, we will get all the statistical information, statistical description of our data. So here you can see that we are getting count, we are getting mean of the respective column, we are getting standard deviation of the respective column, minimum value, maximum value, 25 percentile, 50 percentile, and 75 percentile. Okay. Now I want to save this state's data that I have created. I want to save this state data. So I can save this data also. I can save this data also using pandas. So I can create a new a data. I can create a data in pandas and save it. So I am saving it. So state dot to underscore CSV. And I'm saving it to state dot CSV. Okay, I'm saving it to state dot CSV. So I have saved it. I have saved it. Where it got saved? In my present working directory. So I have printed the list. So you can see that state.csv is here. So now I have saved the data. What if I want to load the same data? I want to load the same data or any other data if I want to load. So simply you just have to write, I'm creating a new variable that is df is equals to pd dot read I'm reading it into df. So here, if I print the df, I'll be getting this data. Okay. So here, what happens is this, the first column that was my index is considered as a new column that is an unnamed column. So we can rename this column. So we can rename this column. So how can we rename? Df dot rename columns equals to unnamed 0, and this should be inside quotes. Unnamed 0 as as I want to rename it as state. Okay. I got it as state here. I got it as state here. But if I print df again, I will not get it. Why? I have renamed it only already, but I did not get it because the changes I have made here are not permanent. So to make the change permanent, to make the change to reflect on this data, I have to give in place is equals to true. In place is equals to true. Then we'll be having as, then if you print df, you will get it as state. So in place is equals to true is used to make the changes permanent. If we are not giving in place value, by default it is false. That means the changes will be reflected for this column only, that will not be reflected to the data frame. So now the next is, we have indexers. We have different indexes that are log and ilog. So let us know the difference between this log and ilog. So I am creating a new data frame, like a series, not data frame, a series, pd dot series, and in this series the data is a, comma b, comma c, and the index I am giving here is index equals to 1, 3, 5. Okay. Now I want to check the data. Now, if I print data 1, it will give me the value of the first index. This index value I will get. This index value I will get. Now, if I want data from 1 to 3, from 1 to 3, so I'll be getting these values. I will be getting these values. But why? But why in 1 to 3 I should get these values, right? I should get these values in 1 to 3, 1 to 3, because 1 is this and 3 is this. So basically what happen is, data dot ilog of 1 to 3. This will give you integral location values of 1, 2, 3. So here the integral values will be, if we take the integral values, this is 0 by default, 1 and 2. Okay. So in that case, from 1 to 3, that is from 1 to 2 will be printed. But if I want to take these index, if I want to take do the indexing based on these index, then I have to do data dot log. Instead of ilog, I have to give log of 1 to 3. then I will be getting these indexes. So ILOC is basically integral index. So it will give me the value of the integral index. Okay, so it will not give me the value of the defined index. If I want the value from the defined index, so I have to give it like lock. Okay. So now let us see how to handle null values. Let us see how to handle null values. Handle null values. Sorry, handling missing data. Okay. So where 1 equals to, I'm creating a numpy array, np dot array of 1, 2, none, 4. Okay. Sorry, this should be inside the array, inside the list. So print var 1. So this is the variable we have created, var 1. Okay. So it has array, and the array has 4 values, 1, 3, none, and 4. So now I have one none value here. I have one none value here. So if I perform var1 dot sum, if I want to perform sum, will I be able to perform? No. It will give me an error because integer value cannot perform addition with none type value. Okay. So none in for none type value we cannot perform addition. But I'm creating this var2. I'm creating a new variable var2, and here I am giving np dot nan. Nan is not a number. Okay. With nan value, I will be able to perform sum, but the nan value, if I perform nan value with the sum with the nan value, so it will give me a nan value. Okay. So whatever function you perform with the nan value, if you plus any number to np.nan, that will become nan. If you perform any multiplication, I am performing 100 multiplied by np.nan, it will be a nan value. If you perform sum, if you will try to find max of var2, nan. If I want to find minimum, Any operation if you want to perform with nan, it will give you nan value. Any numerical function you perform with nan, it will give you nan value. Okay. So this is why we need to treat this is why we need to treat null values. This is why we need to treat null values, because we will not be able to perform the operations on the null values. Okay. So in NumPy, if I want to handle the null value here, so what will I do? I will simply np dot nan sum. I will simply do nan sum here for var2. Then I'll be getting the value. I can perform minimum and maximum also in the same way. np dot so what does nan function do? Nan function allow us nan sum, nan min, nan max will allow us to perform numerical operation with null values. Ignoring the null value, it will give us the sum or minimum or the maximum. Okay. So now let us perform some functions on the null values. Let us perform some functions on the null values. So I am creating a new variable, x is equals to pd dot series 1 comma, second value is np dot nan comma 5 comma none. Okay. So I have taken np dot nan value also. I have taken none value also. Okay. So here I'll be showing you the some operations with both of these. Okay. So here in pandas, if I print x, so np dot nan value is also nan here, and none value is also nan here. So here in NumPy, these are different. But when it comes to pandas, these both are considered null values only. These both are considered null values only. Okay. So x, I want to check how many null values are there in my data set. So this is a very small data set. If you have very big data set, so then this function is useful. Okay. So what will isNull do? isNull will tell if there is any null value in 0th row, false. In first, true. Second, false. Third, true. So true means it has null values, and false means it do not have null values. So nan and none both are considered as null value here. Now if here we have only here we have series, that is a 1D array. I want to find the sum of the null values. That means how many null values do I have. So it will give me the sum of the null values I have. Okay. Similarly, we can check the not null values. Not not null values. And similarly, we can perform the sum of not null. Now, we have the null values. How can we treat them? How can we treat them? The first thing we can do is we can drop null value. What it is giving? It is giving the 0th index and second index value only. The null values are being dropped. Okay. Then I have not placed in place here, so that is why the changes made are not reflected here. So now if I perform x dot fill na, and fill na with 0, I want all the null values to be replaced with 0. So this is how we can fill the values. Also, we have different methods to fill. Forward fill, backward fill we have. Okay. So we can use those methods also. So F fill. Method F fill. Okay. So what happens in forward fill is the previous value is filled to the forward column. So this 1 will be forwarded to the next and this 5 will be forwarded to the next. We have another method that is backward fill. That is backward fill. Here what happens? The value will be filled in the backward way. So 5 will be filled here, 1 will, above 1 there is no value, so 1 will not be filled anywhere. And below nan there is no value, so nan will not be filled here. Okay. So this is how we can fill the null values. Also, if we have a bigger data set, so dropping the value will affect the accuracy of the model. So, and there I cannot fill the values with 0. So we have different method to fill. We have different method to fill. So those method we can use, we use our statistical method. So we can use mean, mode and median. So we will learn further about the handling of missing data in tomorrow's session. Then we will start with data preprocessing. So this was all about pandas. Now let us get started with analysis of our data, performing data visualization. So now we are getting started with data analytics part. So here we are not using any tool. We are using Matplotlib and Seaborn to perform data visualization. Okay. So now let us perform data visualization. So let us create a new notebook. I am going back to the project from here. I am going back to the project from here. I'll click on this navigation and then go back to the project. I'm creating a new asset, that is a new notebook. Again, the code editor I am taking is Jupyter Notebook Editor. And here I am creating the notebook name as day 2. So I have again go back to my project. Then from there, I have selected the asset Jupyter Notebook, and from there, I'm creating a new notebook named Day 2 Data Visualization. You can continue in the same notebook. I am creating a new notebook so that there is less fumble. So we are getting started with matplotlib here. We are getting started with matplotlib. So let us import matplotlib. So import, there are two ways to import matplotlib. So import matplotlib dot pyplot as plt, or the other option you can use is from matplotlib import pyplot as plt. Okay, so these are the two way you can import matplotlib. You can import matplotlib. Okay, so I am commenting one. So import matplotlib.pyplot as plt. So this is how you can import matplotlib. Now here I am just using a graph styling. I am just giving some style to my graph here using plt dot styling dot use and giving the name of the style, that is seaborne dark grid. Okay. Fine. So here we can plot a different type of, many different type of graphs. Okay. So we are first starting with the simple graph. For that, we first have to create the data for x and y axis. So I am creating, for creating the data, I am importing NumPy first. So now I am going to create the data. X is equals to np dot array of some values 1, 2, 3, 4, 5. Okay. And then in y, I'm using the function np dot power x comma 3. Okay. So first let us check the value of y. If you check the value of y, this is cube of 1, cube of 2, cube of 3, cube of 4, cube of 5, and cube of 6. How it become cube? Because I have used np dot power function. Power function, when we pass data and some value to the power function, so the data is then converted, data we get is the power that is given here of this data. So we will get cube of all these values, as I have given the number 3 here. If I have given the number square here, so we would have got squared values. We would have got squared values. Yes, we need to import NumPy because we need to create data. So I'm using NumPy to create data. Okay. So here I have created x and y. Now I am creating a simple line plot. So what I will do, PLT, that is the alias for this matplotlib.py plot, PLT dot plot, plot x comma y, plot x comma y. So you can see we have got a graph here, a line graph here. So plot function is used to plot a line graph. Plot function is used to plot a line graph. Okay. Now let us create another graph with different inputs. X is equals to np dot linspace 0 to 10 comma 100. Okay. From 0 to 10, I'm taking 100 values, and y is equals to np dot sign value. I hope you all know, we all are familiar with the trigonometric sign values. So I am plotting a sign graph here. I am plotting a sign graph here. So PLT dot plot x comma y. So we will get the sign graph here. So we are all familiar with this graph, and we all know this graph. This is the sign graph. Similarly, we can form different graphs. Okay. So now I have formed this graph. Now I want to give some title to this graph. So plt dot title. Title I want to give is sine graph. Okay. I want to give labels to my axis. Plt dot x label. X label is the label that I want to give to the x axis. So to the x axis, I want to give x axis. Similarly, to the y axis, I want to give plt dot y label y axis. Let us see. So you can see we have got the title. You can see we have got the label here as y-axis, and here we have got it as x-axis. Okay. So now if I want to change the color of this graph, I want to change the color of this line graph. I want to change the color to green. I will give G only. I want to change the size of this. I want to change the size of this. So plt dot figure size. Figure and the parameter fig size is used to resize the graph. Sorry, it is F. Okay, you can see the size of the graph has changed. Okay. Now I do not want this line like this here. Instead of this line, I want to plot the dots here. So this is how I can plot the dot. O. O here represents the dot. G represents the color. O represents the dot. If I want the, instead of this dot, I want triangles. So I will use this cap sign for the triangles. And I'll get the triangles. I'll get the triangles here. Okay. So this is all about a line graph. This is all about the line graph. Now let us perform a bar graph. Let us build a bar graph. Okay. So I am building a bar graph. And here I am taking the name. I'm taking the name as Amit. any random names I have taken. Okay, and I am going to plot the bar. So PLT dot bar. Bar is used to plot the bar graph. So you can see the bar graph. If you want to change the size, you can use the same thing. PLT dot fix size. If you want to change the color, you can change the color also. So you can define the color here. I am defining the color as yellow. So you will get the color as yellow. Let us change the color. I'm giving it yellow green color. So we are getting this yellow green color. Okay. So we can plot multiple plots here. So we can also plot multiple plots. Okay. So how do we plot multiple plots? Uh, X is equals to NP dot lin space. I'm creating a linearly spaced array from 0 to 10, and it will give me 40 values. Y1 I am creating is the sign value of X, and in Y2 I am creating the cost value of X. So I'll be plotting sine and cos graph for these X values. Okay. And now I will be using subplot. I will be using subplot for multiple plots. Subplot for multiple plots. Okay. So PLT dot subplot is used to plot PLT X comma Y1 comma color is red, then PLT dot subplot 2 comma 1 comma 2, PLT plot PLT dot plot of X comma Y2 and color I'm giving as green. Okay. So let us see the subplot. So here in the subplot, if you see the different values here, I have given 2, 1, 1 and 2, 1, 2. What does this 2, 1, 1 and 2, 1, 2 stand? 2 stands for rows, 1 stands for column, and this one is this one value and this is the second value. So I am taking 2 rows, 1 column, and in the first value I have this sign plot, and in the second value I have this uh, cost plot. So now if I change this, if I'm taking 2 rows and 2 columns and I'm giving it an 4, let us see. So now you will see. So 2 rows, 2 columns, and this is the second, third, fourth. So this is the fourth value I am getting here. So first and fourth. So this is how we are getting the subplot. This is how we are getting the subplot. Okay. Understood? So I hope it is clear. The subplot thing is clear. If you have any doubts, you can ask. Yeah, that is what I'm telling. Two, this first two is this first two is rows, this is columns, and this is the value. So previously I have given, okay. So here we have two rows, 2 columns, 1 and 2. These 2 columns, and this is the first value, first, second, third, fourth. So I am having the sign plot as the first value and the first plot as the fourth value. So this is how we are having different values. So now let us have a scatter plot. So I am plotting a scatter plot. So I am creating some data x1. Let us take x1. X is equals to np dot array of some values like 250, 100, 1. Okay, and similarly we will have y values also. Forty, 50, 10, 20, 30. Now let us plot a scatter plot. So plt dot scatter is used to plot a scatter plot. X1, comma y1. Sorry, I have named as x and y. So x and y. X and y. So this is how we can get a scatter plot. This is how we can get a scatter plot. Then then we have pie chart. Then we have pie chart. So let us create and let us plot a pie chart. Area 40. 20 and okay. Labels I am taking. Low, high, medium, and critical. Colors. Okay, so I have created this data. Area is equals to this, and labels. Labels I have given low, high, medium, and critical. And colors I have given these. Now let us plot a pie chart. CLT dot pie is used to plot a pie chart. I'm plotting pie chart for area, giving the labels as labels, colors as colors, and okay. So we will be getting a pie chart like this. We'll be getting a pie chart like this. Okay. So now, if you see my start angle is this, my start angle is this. From here, it is getting started. Now, if I want to change the start angle. So this is 0th degree here. It starts from here 0th. So I want to start it from 45. So now you see it will start from 45. You can see it is starting from here. If I change it to 90, it will start from 90. It will start from 90. Okay. So this is what a pie chart is. Now let us have a histogram. Now let us have a histogram. How to show percentage in pie chart? So for percentage, you can simply use this auto PCT. mm, mm, Auto PCT. mm, This auto PCT you can use to show the percentage. Okay, so this is how you can show the percentage. Then we have histogram. X is equals to np dot random dot normal. I'm creating some data. Size equals to 1000. So dot hist function is used to plot a histogram. So you can see the plot here. You can see the plot here. This is how you will get the plot. Um, Let me color its edges also. Edge color equals to so this is how you will get a histogram. So we are done with matplotlib. We are done with matplotlib. We are done with matplotlib. Now let us begin with Seaborn. Let us begin with Seaborn. So for Seaborn, we have to import Seaborn first. Import Seaborn as SNS. So let me tell you that unlike matplotlib in Seaborn, we have some like some predefined data set, some pre-stored data set we have in Seaborn, so that we can load those data set and we can perform visualizations on the data set. So now let us first check the list of the data set. Okay, so I am printing the list of the data set. So here in Seaborn, we closely work with pandas data frame. So I am importing pandas also here. Okay, so now let us print the list of SNS data set, Seaborn data set. So SNS.get dataset names will help us to get the dataset name. So these are the different data sets that are present inside Seaborn, that are pre-defined inside the Seaborn library. We can just load these data sets and we can use these data sets. So for example, I'll be loading car crash one. So car, I'm creating a variable car and I am loading SNS dot load underscore data set is used to load Seaborn data set and giving the data set name, that is car crashes. So this is how we can load the data set. Okay, now let me check the data set. So this is the data set. Okay, so here we will be working on a case study to perform data visualization on Seaborn data tips data on Seaborn tips data. So let us load the tips data. Let us load the tips data. Tips is equals to SNS dot load and dataset name is tips data. So here you can see we have this tips data. We have this tips data. Okay, so I am loading this tips data. Now let us check the tips data. So here we have total bill, tips, check, I hope I'm audible now. I hope I am audible now. Okay. So I have loaded the tips data set and I am explaining what the tips data set is about. So here we have tips data set. So we'll be performing data visualization on tips data set. So we have here total bill, tips, sex, smoker, day, time and size. So size of two, that is two female visited on Sunday at dinner time. Those females are not smokers. Their total bill was this and they have given the tip of this. They have offered the tip of $1.01 or whatever currency. Okay. So this is what our tips data set is. So this is what our tips data set is. Now let us perform some data visualizations on this tips data. Okay. Let us perform some data visualization on this tips data. So let us first perform a scatter plot. Let us first perform a scatter plot. So SNS dot scatter plot. So here I am giving X as my size from the data set. So size, this size I am giving. Size and Y equals to the tip. So I am plotting the graph between size and tip and from the data tip. Okay. So here we have to define X and Y from the data and we have to give the data also that I am taking data from the tips data. Okay. So the data is tips, data set is tips, from tips X is size and Y is tip. So let us plot a scatter plot. So you can see the maximum tip has been offered by the size of 4 and there is one exception in the case of 3. Otherwise, the maximum tip has been offered by the size of 4. Okay. And the size of 2 has given more tips. Okay. Then let us plot a line plot. SNS dot line plot. SNS dot line plot. Here also so you can see the line plot here. So the maximum tips are offered by 4. Okay. So we have used two different graphs for the same plot. So let me tell you that scatter plot and line plot are used for numerical type of data. When we have numerical type of data to perform visualization on, we can use these. How to load GitHub or Kaggle data set? You can simply download the dataset and you can load the dataset in PD. PD.read CSV function is used to read any data, any CSV data, or PD.read underscore Excel is used to read any Excel data. So PD will be used. Okay. that is pandas will be used to load the data set. So pandas allows us to load the data set. Now let us plot a bar plot. SNS dot bar plot. We have x is equals to day and y is equals to tips. So here we are checking that on what day more tips are being offered. On what day more tips are being offered. Okay, so you can see on Sundays the more tips are being offered. On Sunday the more tips are being offered. So whenever you have to plot between a categorical value and a numerical value, whenever you have to plot between a categorical and numerical value, then you use then we can use bar plot. Then SNS dot box plot. Very useful visualization and very insightful visualization is given by box plot. It gives the statistical visualization, statistical plot of the data. Okay, so now let me explain this visualization. Along with this tips dot describe. So here you can see the minimum and the maximum value. Here you can see the minimum and the maximum value, right? So in case of size, if you see this, the lowest point is the minimum value. This is the maximum value. Then this is 25 percentile. That is, this is the first quadrant. Then this is 50 percentile. That is median. 50 percentile, second quartile. And then this is 75 percentile. That is third quartile. So this plot gives us the statistical description of our data. This plot gives us the statistical description of our data. Okay, so when we need to get statistical info, then we use box plot. Then we have cat plot. SNS dot cat plot. Cat plot is used when we have categorical data and numerical data. When we have to plot between a categorical and a numerical data, then we use cat plot. So smoker is a categorical data if the person visited was a smoker or not. And what is the tip offered? From the data tip. Okay, so here you can see that smoker and non-smoker. This is dense, so we can say that the non-smoker has offered more tips. Okay, so we can say that the non-smoker has offered more tips. Now the next visualization we have SNS dot count plot. So count plot is a univariate type of plot. Is a univariate plot. It this plot will count the number of smokers and non-smokers. Okay, so you can say that this is a univariate plot that is plotted for categorical value. Okay, univariate is basically when we are taking only one feature into the count, we are plotting, we are visualizing only one feature. If we are taking two features, then it is bivariate. If we are taking multiple features, then it is multivariate visualization. So as the case study, we have visualized the tips data set. So we have performed some visualization on the tips data set. You can explore more and perform more visualization on tips data set. So let us have one more visualization that is also very important when it comes to the term of modeling. So in future, we are going to do data modeling. So now let us perform this visualization also. So this visualization is heat map. This is heat map. So please keep in mind that this visualization will be plotted for only the numerical value. For the categorical value, it will not be plotted. Like for the textual value, it will not be plotted. So it is taking count only the numerical features, that is tip size and total bill. And it is giving us the correlation. So what is correlation? What is correlation? To understand this visualization, we first need to understand what is correlation. Correlation is nothing but the correlation tells us how correlated the different columns are. Okay, if the value of the correlation can vary from -1 to +1. If it is nearest to +1, then it is highly correlated. If it is nearest to -1, then it is highly inversely correlated. And if it is between 0.5 to -0.5, that means it has no effect on other columns. Okay. So here you can see that lighter the color is, the higher the correlated the values are. Okay. So if you want to see the values of the correlation here, so you have to give annotate is equals to true. That is annotations is equals to true. Then you can see the percentage. Okay. So the value above 0.5 are considered to be correlated. So total bill and tips are correlated. Okay. Total bill and size is correlated. Total bill and tips is correlated. Okay. So this is what we had to do for Seaborn. You can explore more visualizations and perform visualizations on the different data sets. So we have different data sets here. As I have loaded these, I have checked the list for this data set. So you have multiple data sets here. So you can perform visualization on any of these and draw insights from the visualization. So that's it for today. I hope you guys have enjoyed the session. Yeah, I'll be sharing these files to you. I'll be sharing these files on Telegram group. So I request you all to please join Telegram group as already 15 minutes are up. So now we are open to questions and queries. If you have any questions and queries, you can ask. If we have any questions and queries, you can ask. We can use subplot there. Pandas will be used to load the dataset from Kaggle. You can download the dataset from Kaggle or GitHub and load using Pandas, or you can simply trigger the Kaggle API. Two graphs in one plot can be plotted using subplot. Those who have missed it, the recordings will be provided. So can you please, you guys can please go through the video and check it. Telegram group channel will be shared here by the mentors. I am also sharing it. Telegram group link is shared. Soumya has also shared and I have also shared. Thank you all for your valuable comments. So hope to see you all tomorrow. Thank you all. We are ending the session. So any further queries, if you have any further queries, you can get back to us on Telegram group. We'll be happy to help you out.